Hi, this is Mrs. Kidman, and in this video, we are going to be discussing how we can look at the angles and how we can use those angles to talk about other angles. Now, this was kind of mentioned previously in a different video, but what we're going to do is we're going to start by drawing an angle with the given measurement. And then we want to state which quadrant the endpoint of this angle is located in. So that pi over 3, remember, we filled out our unit circle before, and pi over 3 actually ends up being over in this quadrant, and it's going to be up here like this. So this is going to be in quadrant 1. Now that's going to be our angle here, as we get this angle that looks like this, meaning that if we have pi over 3, that's our radian, meaning that we've got this part of our circle here. Now, what about a negative radian? Well, a negative radian, notice how this one went up counterclockwise. A negative radian actually goes clockwise, and it's going the other way. So negative pi over 2 is actually going to go this way, and it's going to be right here. And so it's actually going to be between quadrant 3 and quadrant 4. It's going to be right on that border there because it's right at that negative pi over 2. Then we have our last one, which is 7 pi over 6. Now, to help us kind of visualize where these go, this one up here, over on our side here, our x-axis, we have 0 pi or 2 pi. Up here at the top, we've got pi over 2. On the left here, we've got 1 pi, and on the bottom, we have 3 pi over 2. So when we're trying to decide where these are located, using those 4 origin points can kind of help us decide. Now, 7 pi over 6 is greater than 1, but it's less than 3 pi over 2. So that means that this is actually going to be over here, and we know it's going to be in quadrant 3. Isn't that awesome? Now, when we saw this, we saw both those positive and negative radians. So how does that affect it? Well, these are called coterminal angles. So coterminal angles are angles that are the same, but they have a different name. So sometimes we will see them, for example, as being 330 degrees and negative 30 degrees. So 330 degrees says we start here, and I'm going to go 330 degrees this way. So my angle measurement is going to be this side of it, and it gets me to this point. The coterminal side of it is negative 30, which is going the other way, but it still gets me to this point. So we're going different directions. But as we go these different directions, we're still arriving at that same place on our unit circle. So what we're going to do here is we're going to just practice finding these coterminal angles so that we know that these are actually the same as one another. And so if we don't want to do 330 degrees, we can actually do negative 30 and it's going to be the same. So what about if we had something like 60 degrees? What is the coterminal angle, or the same angle with a different name, as 60 degrees? Well, the way that we find them when we're given a degrees is we either add 360 if it is a negative degree, or we subtract if it's a positive degree. So we have a positive degree here of 60 degrees. So to figure out where its negative counterpart is, what we're going to do is subtract 360 from it. And so 60 is the same as negative 300 degrees. So I can either go negative 300 this way, or I can go 60 degrees this way. It's totally up to you. Same place, different angle. What about this one, that 127? Again, same sort of thing. I can subtract 360, and when we do 127 minus that 360, we end up getting negative 233 degrees. So that is going to be that coterminal or its counterpart. Now, what about what happens when we have radians instead? Well, radians, just like with degrees, we're going to add or subtract the whole of the circle. So the whole of the circle in degrees is 360. In radians, it's 2 pi. So we're going to add it if we start with a negative number. We're going to subtract it if we start with a positive number, and we can find that. Now, the cool thing about radians and degrees is you can continue going around your circle as many times as you want. So you'll see here with this example where we have a 14 pi over 3, we can actually just simplify that, figure out how many times that goes around 2 pi, and find other coterminal angles there. So this pi over 6, I can add 2 pi to it, and I can find out that this is actually going to be, so pi over 6 plus 2 pi will end up being 13 pi over 6. Or we can subtract 2 pi from it. And if we subtract 2 pi from it, we end up getting, so 2 pi, as you're trying to figure out how I'm getting these numbers in my head, 2 pi is the same as 12 pi over 6. So we can subtract it, and that's also the same as negative 11 pi over 6. Got it? Now, what about this 14 pi over 3? Well, 14 pi over 3 is actually the same thing as being 4 wholes and 2 pi over 3s. Well, 4 wholes is 2 pi's over and over again, right? So 2 full pi's. And so really this 14 pi over 3 is actually the exact same thing as 2 pi over 3. Isn't that awesome? So that is kind of how those coterminal angles work. If you have questions about it, please ask, but we can use these different angles and these different angle measurements or different radian lengths to determine different things. And so sometimes it's more helpful to know that something is a negative angle versus a positive angle, depending on how the question is worded. So please reach out if you have any questions, but that is how we can find those different angle measurements.